This is the final E101 presentation for the Bucketeers of Section 25, including Sydney Tyson, Katarina McGarry, Nathan Bowers, and Harrison Stragg.
So on FEDD Day, our fabric bucket was fairly successful. It was able to complete the base requirement of holding 1 gallon of water for 1 minute, and it fit in a 6x6 box. And our fabric bucket in total was able to hold around 2.5-3 gallons of water, so it was very competitive on the amount of water it could hold. But what really cost us points was the weight of our fabric bucket. Our fabric bucket was one of the heaviest, if not the heaviest, and that severely cut our score, which caused us to be in 4th place. But I'd say we were a success just because we were able to complete the requirements.
The engineering design process has 5 core elements: ask, imagine, plan, create, and improve. For ask, you're asking questions like what your design is supposed to do, how you'll know if it's working, how to test it, etc. These types of questions are covered by our assignment itself, the rubric for FEDD. However, we also continue to ask and enhance our ideas through our own creativity and our own idea of what we want it to be. The next step is imagine. So we build off of these questions we asked. We asked what it's going to do, how we can make it do it, and we start to imagine solutions for those. So we are applying our knowledge and our research. This is where the research component takes place. So when we look up what materials are best for what things, hydrophilic versus hydrophobic, etc., that goes under imagine. And so planning, you have to collect your materials and also form an idea of what we're going to do. So in this step, we collected our materials, we collected the canvas, and we collected the laminates, the Flex Seal, liquid nail, and paraffin wax. We then need to incorporate these into a sketch and plan how we're going to mesh these 2 ideas together. The next step, create, is where we follow the plan. We put it together. So this is where we apply the laminates ourselves and create the waterproof fabric with the canvas, and we also start sewing it together and creating the bucket itself. We also start to test our results here. The last step in the engineering design process is improve, where we continue testing, analyze these test results, and then use them to improve our design. So we would pour water into our bucket, see how much water we could put in before it started leaking, see where it leaked, and then apply more laminate to those spots. At the end of the design process, we have a fully functioning waterproof bucket.
Some of our biggest challenges during the design process included how to make the material waterproof and to create a watertight seam. Our research concluded that duck canvas would be our main fabric. It is a tightly woven material that only has very small gaps in the weave. We also looked into nylon and polyester. These are both woven materials as well, but with a synthetic fiber instead of a cotton fiber. We ended up testing with both duck canvas and polyester. Next, our step was to choose a laminate material. We decided on a paraffin wax and Flex Seal to ensure that there was no leaking. To apply the wax, you can melt it and paint it on, or rub the solid wax on and use a heat source to melt it into the material itself, which was much more successful for us. Our plan was to wax the polyester and Flex Seal the canvas and layer the 2 in our bucket. However, this did not work. After testing both fabrics separately and together, our bucket leaked like a sieve. We then added more Flex Seal to the canvas, waxed the opposite side, and got rid of the polyester altogether. The wax soaked into the canvas a lot better than the polyester because of those small gaps in the weave. We tested again, it was better, but it still leaked. So we added liquid nails, which is an unconventional clear adhesive. However, it worked really well to seal the small areas the water was getting through. Finally, with all 3 laminates, there were no leaks and it was time to sew. We planned to make a drawstring style backpack to eliminate any seams that would be weak points. For the strap design, we used a cotton and synthetic knit that stretched into a baby sling style strap. The machine had a really hard time getting through the stiff material, creating a really sloppy stitch at first. I then tried to lace the rope through the drawstring hem, but the liquid nails had stuck together, making it impossible to push the rope through. I ended up having to take the whole seam out and re-sew it with the rope already in it. This time I sewed much slower, using a nylon polyester thread instead of a polyester thread, and got a much cleaner stitch. Once the hem was done, we coated it with a little bit more liquid nails to seal those tiny holes the needle had made. Now our backpack was sealed, sewn, and complete.
When reflecting back on our FEDD project, we would have gone about the design cycle and the design of our bucket itself a bit differently. First of all, we would not have done an oval design. The sides had extra fabric once it was completely filled with water, so it was just a waste of fabric and added extra mass to our bucket. We would have done a more of a circular shape if we did it again. In our testing, we never tried to see how much water it could hold, we just made sure it could hold a gallon, so we were unaware of this before FEDD Day. Second, we would have liked to have found a different way to close the bag. We did a drawstring design, and it was difficult to pull close due to the stickiness of our fabric from the laminate. We also had extra rope, which we should have cut off to reduce the mass. We would also like to have improved on our testing of laminates. We only tested Flex Seal on canvas and the wax on the polyester. We later realized that perhaps we should have tested the Flex Seal on the polyester and the wax on the canvas. This might have been more beneficial to holding the water in, and the polyester itself would have been a lighter fabric and may have just been good only flex sealing polyester.
So for next year's incoming freshmen, I would first recommend them to test early because this project requires a lot of trial and error and to see which limitations you can improve on before FEDD Day. And also with your designs, you can think out of the box and be creative and have really cool designs if you want to have fun with the project, because that also gets you some multipliers. Also, I heavily encourage you to think about the weight of the design, because the weight impacts your score a lot. Even though our fabric bucket held some of the most water from all the fabric buckets, since it was so heavy, that ratio wasn't big enough to get us enough points. So if you create a very small fabric bucket that holds water, that holds not as much water, but that ratio still, there's a big difference in the ratio, you can score a lot of points. So just think about that. And also construct a fabric bucket that can easily be folded and doesn't damage when you do fold it, because they put it in a 6x6x6 box to weigh it. And so, we had this problem this year. We thought our fabric bucket was messed up because some part of it on the inside stuck to each other and some part of the laminate came off, so we were worried about that. Even though we still fulfilled the requirement, we were still worried about that. So that's something to look out for.